So starting off, we have the standard form of a quadratic. That means it's FOILed out. It's all in separate terms as ax squared plus bx plus c. So in order to use the quadratic formula today, which is the first thing we're going to learn, we need to be able to identify a, b, and c. So we're going to practice a few of these. So if you want to write these down, you can. If not, we're just going to kind of do a quick practice. So let's say we have the quadratic 2x squared minus 4x plus 10 equals 0. What is my a value? 2. Now, it's not 2x squared. It's the coefficient. It's the number in front of x squared. Okay, what is my b value? Negative 4. Good. You have to include the negative. That will throw everything off. You have to include the sign in front. And c is 10. Okay. Next one. Just going to practice a few of these. Like I said, you don't have to write them all down, but let's say I have 2x minus 3x squared plus 10 equals 2. So first of all, what is my a value? Yeah, it is negative. Why is it not 2? 2 is in front. You hear what I said? You're right. Yeah, it has to be. I'm talking about the x squared. It's not necessarily always the number in front. It's the number in front of x squared. So it would be negative 3. Okay, what is my b value? Yeah, it's the number in front of x, which is 2. What about c? It would be 8. Where'd you get that from? I don't even see the number 8 up there. Yeah, it has to be set equal to 0. So if it's not, you need to combine your constants, which gives us 8. Okay. Couple more. Let's say we have 3x squared minus 9 equals 0. What is a? Good. What is b? It's 0. Good. Why is it 0? There is no x. That means 0 times x canceled it out, and there's no x anymore. So it's 0. And c is not 9. Negative 9. That will change your answer totally, so be careful. Include that number. What about x squared equals 15? What is a? What is b? What is c? Negative, right? You have to get it set equal to 0. So it'd be x squared minus 15 equals 0. So c is negative 15. Okay, those are kind of... next, why do we use the quadratic formula? Can't we just factor and set it equal to 0? So let's say I have x squared minus 9 equals 0. We just learned how to factor this. That's called the difference of two squares. So we factor it, right? X plus 3, x minus 3. And then how do you solve a quadratic after it's been factored? Yeah, we're trying to find all the scenarios in which x equals 0. That's the whole point of this. So x equals 0. So what we do is we set each factor equal to 0. We get negative 3, and we get positive 3. We're done. We solved it. But let's take a look at the one I have here. How do I factor something with 3 terms? Yeah, a times c, bottoms up. So what is 2 times 13? Okay, find the factors of 26 that add up to negative 4. Well, we could do 1 and 26, which either adds up to 27 or negative 27. What other factors of 26 do we have? Yeah, the 2 that we just multiplied. So what's 2 plus 13? 15. Are we getting to negative 4 anyway? No, it's not possible. So the way we solve a quadratic when it doesn't factor is the quadratic formula. So what is A? What is B? C? 13. Plug it into the quadratic formula and solve. So if you need a little refresher, now we're on the front side of your notes. We're now to the point that I actually printed out. So up at the top is the beautiful quadratic formula. The discriminant is this. You might remember it from Algebra 2. It's what's under the square root. It's b squared minus 4ac. So let's say the quadratic formula is, let's say I have x equals -2 plus or minus the square root of 13 all over 4. What's the discriminant? 13, period. It's not the square root of 13. It's the number under the square root. It's just 13, okay? So that is the discriminant. So we're going to watch a little video real quick over what the discriminant tells us. And what do I always need to do first? Yep, do ABC, but even before that, get it equal to 0. So C in this case will actually be -28, right? Because if I solve this for 0, I need to subtract that 28 to the left. So we actually have this quadratic equals 0, right? So I like to identify what is A. What is A? 1, what is B? -12, and C is -28. So we're going to kind of do this in 3 steps. This is what your test will look like. So the discriminant is b squared minus 4ac. So, what is b? Yeah, you need to put this in parentheses, because a negative number squared, that negative has to be included in the squaring. Minus 4 times 1 times -28. See how I'm using parentheses for multiplication? I really suggest doing that because it will set you up to enter it in your calculator correctly so that you don't miss any negatives in the squarings or the multiplication. So now, get out your calculator. I know math teachers don't say this a lot, but I really want you to just throw this all in your calculator. So I'll show you the best way to do that. Okay, so go ahead and type in parentheses, -12 parentheses to the second power. And I really would just put it all in there. Okay, so then I do -4, and then parentheses, 1, parentheses, -28. And your calculator recognizes parentheses bumped up next to each other as multiplication. So then just hit enter, and that is your discriminant. So 256. Now real quick, why is -12 squared in parentheses different than -12 squared without parentheses? Yeah, you need the negative to be included in the squaring. In other words, I want this to be -12 times -12. Gives me a positive. Not negative times 12 squared. That gives me the negative. We need the positive version of it. Okay? So I just always put it in parentheses. So we got, what was it, 256? That is your answer for the discriminant. So if on a test it asks you what's the discriminant, it's just the number that you got from b squared minus 4ac. Okay, so now that tells us how many and what type of answers we're ultimately going to get. So how many answers, what scenario is this? Yeah, the discriminant was positive, so we're going to get 2 real solutions. They might be positive, they might be negative, but they're going to be actual real numbers, like integers or rational numbers. That's 2 real. Yes. Now, lastly, just put it all together. So now we're going to finish off the quadratic formula. X equals negative. B was -12. So correct, it is going to be positive, but I'll go and write that for now. Plus or minus the square root of, now we just did this. We don't need to do it again. What was b squared minus 4ac? 256. But don't forget your square root this time. All over 2 times a was 1, so 2 times 1 is 2. Now my suggestion to you, always see if that's a perfect square first. What is the square root of 256? Yeah, it's a nice pretty number. It's 16. So this is ultimately going to be positive 12, because minus a negative, plus or minus 16 all over 2. Now this is really 2 answers, all built into one, but it's 2 answers. we have 12 plus 16 divided by 2. And we also have the minus version of it, 12 minus 16 divided by 2. So we're going to get two totally different answers here. So what is 12 plus 16? 28 divided by 2 means one of our x-intercepts is 14. Then the other one, 12 minus 16 divided by 2, means our other x-intercept is negative 2. So this is a parabola that has x-intercepts of 14 and negative 2. And I know it opens up because the a value is positive, if you remember that back from algebra 1, but kind of a big sketch there. All right.
Actually, parabola.
Parabola. Why did we get pretty answers? Those were pretty answers, like integers. That tells me that this actually factors. What factors of negative 28 add up to negative 12? Which is kind of the answer. Minus 14 plus 2. But remember, the answers are the opposites because you have to set them equal to 0. So if I set this equal to 0, I get x equals 14. And so did you have to use the quadratic formula here? No, you could have done a bottoms up in like 5 seconds. But I just want to show you both of them work. So if you do bottoms up, yeah, that's a really easy bottoms up because a is 1. What factors of negative 28 up to negative 12, and it takes like 5 seconds. So you don't have to use quadratic formula on this one. In fact, I suggest you don't, but at least you see it always works. You'll get the same answers. I'm actually going to start this one off by telling you that it factors. Again, what factors of 121 add up to 22? Yeah, 121 is a perfect square. The square root of 121 is 11. So 11 times 11 is 121. And 11 plus 11 adds up to 22. So if I set these equal to 0, what am I going to get? Negative 11 and negative 11. Same thing. So how many and what type of answers do I already know I'm going to get?
1.
Yeah, 1 real. And we also knew that because the discriminant was 0, if you found it, right? Now, hopefully, I wanted you to do the quadratic formula so you can see it still works. But if this was on a test, don't use the quadratic formula. So factor that, okay? But the discriminant is 0, so x equals negative 22 plus or minus the square root of 0 all over 2. So now you can really see how that discriminant works. What's the square root of 0? 0. Right? So what is negative 22 plus 0? What's negative 22 minus 0? So does that matter at all? No, so I can just erase it. What's the only thing left? Which is? Negative 11. Same thing we got from factor. What did you guys get for the discriminant? 56. So we have 2 real solutions. So we get x equals negative 4 plus or minus the square root of 56 all over 2 times 2. Now you do need to do a dates to prom here. Okay, there's going to be no decimal answers allowed on this test. You'll always have simplified radical. So what times what is 56? 8 and 7. 7 is prime, 8 is not. 4 and 2. 2 and 2, which means I have a date, single, single. So what is that whole thing? What is the square root of 56 reduced to? 2 square root of 14. But we still have plus or minus in front, negative 4 all over 4. Now lastly, anytime all 3 sections, and what I mean by sections is the negative b, the discriminant, and the denominator. Anytime all 3 of these, the whole numbers or integers divide by the same number, you need to reduce them. Okay, so each of those divide by 2. So I get negative 2 plus or minus the square root of 14 all over 2. That's your final answer there. You have to write them.